Okay. Who has an answer they're willing to share? Go for it.
X minus 2y is greater than or equal to.
Hold on, I'm not plugged in. Okay, so 1x plus 2y is greater than or equal to. Okay, so let's test this out. We have a y-intercept of -4, right? So if we plug a 0 in for x, what's our y-intercept? So if I have -2y equals -4, y would equal what? 2. Okay. Is that what we have graphed right here? No. Okay. But I like a couple things. Think about those x and y intercepts again. Okay? And we'll come back to you. Okay, Jacob, what do you have?
2x minus y is greater than or equal to 4.
Okay? So, Kaden, look at these numbers, because these are the same numbers that you were using. What I think happened is you got your x and y intercepts mixed up. Right? If we plug a 0 in for x, we have a y-intercept of -4. We plug a 0 in for y, we have an x-intercept of +2. What you had a y-intercept of 2 and an x-intercept of -4. So you had the right numbers going for you. Okay? All right, that's not the only right answer. How many of you had this? A couple people, okay? What's another answer?
4x minus 2y is greater than or equal to 8.
Okay, 4x minus 2y is greater than or equal to 8. We still have a y-intercept of -4 and x-intercept of 2. Our shading is away from 0, 0. Okay? It's different, but it still represents the same linear inequality. Okay? Who else had that one? Okay. Do we have a different answer? Do we have a different one? What if I made this 12? What would need to be the coefficient of x? What would need to be the coefficient of y? 3, right? We need a y-intercept of -4 and an x-intercept of 2. Okay? I gave you this problem of the day because I really want you to think about using that intercept method to graph your lines. Okay? On Thursday, we talked about linear, well, any type of inequalities. Today, we're going to stick with linear inequalities. But we need to take today and practice setting up linear inequalities based on application problems so that when we move into linear programming tomorrow, it's not like brand new. Okay? So we are going to do one example together, and instead of you having to write all of these words down, just make a note to yourself that this is example 9 on page 514. So this is from page 514, example 9. There we go. Don't turn to that in your book because I don't want you to look at the book's work quite yet. But go ahead and read through that scenario. And as a pod, which means you have to talk to each other, as a pod, write down what you think our unknowns are. What is it that we're trying to find? What would be our variables? So read through it and then talk. Talk to each other about what our variables are. What are the unknowns? All right, part 3. What do we think about our variables? You want to come to a decision. Okay. What have you discussed? Okay. Read the last sentence. Well, I see information up here about 60 calories and 12 units of vitamin A and 10 units of vitamin C. So I would say that there are numeric values for the calories and the vitamins. But what numeric values do we not have? It's in the last sentence for you.
How many calories and vitamins we need to consume a day?
Well, here it says your diet should provide 300, 36, and 90. So I would say we have numeric values for that. Okay. Look for the phrase how many. How many cups of each drink should be consumed each day to meet all of the requirements of the 336 and 90? Okay, meet or exceed. That's where inequality is going to come into play. Okay, so we know information about the calories and the vitamins, but we don't know how many cups of X and Y we should drink in order to fulfill that. Okay, so our two variables would be the number of cups for drink X and the number of cups for drink Y. Okay, those are our two unknowns. Okay, now we have information about vitamin A, and we have information about vitamin C, and we have information about calories. Okay, those can now be grouped together for our inequalities. Okay, the first thing I really want you to get in the habit of doing, cups. Okay, have you ever drank -2 cups of water? That doesn't make sense, right? If we're talking about tangible items, we are never going to have negative amounts. Those are always going to be 0 or more. So when we set up a system of inequalities and we're talking about tangible items, we better say that each variable is greater than or equal to 0. Now, we have some information up here. I do want to underline that we need to meet or exceed the daily requirements for calories and vitamins. Meet or exceed. Exceed means we can do what? We can go over, okay? Minimum we need to meet, but we could have more. So I'm going to try to color code things to the best of my ability, okay? Let's see. We need 300 calories in our diet from these drinks, okay? Drink X provides 60 calories, and drink Y provides 60 calories. So when we're talking about an inequality, we want 60 calories times the number of drink X plus 60 calories times the number of drink Y needs to meet or exceed our 300 calorie requirement. Okay, 60 calories from drink X plus 60 calories from drink Y needs to meet or exceed our total calories of 300. All right. What's another inequality? What other information should we group together?
The amount of vitamin A for the amount of units.
All right. So it says 36 units of vitamin A. Okay. Now, typically, I don't think I have anything with a label on it. Typically, is it milligrams or? I think they typically do either grams or milligrams, depending on what they're talking about. But here we just said units. We won't even get into which system we're using. Okay, so 36 units of vitamin A would be our diet requirement. Drink X provides 12 units of vitamin A, and drink Y provides 6 units of vitamin A. Write the inequality to match that. 12 units of vitamin A from drink X, 6 units of vitamin A from drink Y. Needs to meet or exceed 36 units. "12 units from drink X plus 6 units from drink Y needs to meet or exceed the 36 unit requirement." Are we done? Okay. Now we got in the habit of, if I'm solving a system, 2 equations is enough for my 2 variables. Well, yes, that's true, but now when we talk about inequalities, we could have 10 inequalities that we need to meet, okay? We can have lots and lots. So have we used all of the information that is necessary from this diet? Okay, we still have information about what? We still have information about vitamin C. So we need to write an inequality about vitamin C. Okay. So here we go. We have 90 units of vitamin C required for our diet. Drink X provides 10 units and drink Y provides 30 units. So in our inequality, we get 10 units from each cup of drink X plus 30 units from each cup of drink Y, and we need to meet or exceed our 90 unit minimum. Okay. Before we go any further, do you have any questions or clarifications about any of those inequalities? Now what do we get to do with these? We don't have to solve them quite yet. What do we do with inequalities? What do you do on number 4 of your quiz? We get to graph them. We get to graph them and shade all of the overlaps. Okay? Now, I'm going to help you here. X is greater than or equal to 0 and Y is greater than or equal to 0. What part of the coordinate plane is that talking about?
The origin.
The origin's a part of it. What? First quadrant. Y is greater than or equal to 0 means we're above the y-axis. X is greater than or equal to 0 means we're to the right of the x-axis. So we're really just talking about quadrant 1. So that's all I'm going to draw right now because that's all that matters. Okay? Now, do you think that putting these 3 linear well, these three lines into slope-intercept form is going to be efficient. That's a lot of algebra to do, okay? Which is why I've been really stressing the intercept method, okay? When we get numbers that are like this, okay, these are pretty big, okay? I mean, they're not like super big, but I don't want you to make some algebra mistake. Also, our x and y intercepts could be very important, so if we have them already on our graph, it'll be nice. So, let's graph this red line right here. And we're thinking of the equation, okay, let's not worry about the inequality right now. What would our y-intercept be if 60y equals 300? Okay, so 1, 2, 3, 4. Okay, and what about our x-intercept? 60x equals 300.
5.
Also 5. Okay, now I'm color coding up here. So like I see that my red line is going to match the red inequality. If you're not doing that, you may want to label this line in case you need it for algebra later. Okay. Now, I don't want to make this too messy, but would we shade towards or away from 0, 0? What did you say, Sophie? Okay, we would shade away. I'm really not going to do a lot of shading because I don't want to overwhelm my picture up here. I'm just going to make a little note to myself. Okay? All right, let's graph the green line. Okay? Intercept method, like I said, is going to be the most efficient way for you to get these on the graph. If we plug 0 in for x, what would our y-intercept be?
6.
And if I plug 0 in for y, what is our x-intercept? It's 3. Okay. Here again, I have this all color-coded, but if you don't, I'm going to go ahead and label that this is 12x plus 6y equals 36 so that I know which line that is. Okay? And would we shade towards or away from 0, 0? We would shade away because 0, 0 wouldn't work. Okay. Okay. And then our purple line. What would our y-intercept be? 3. And our x-intercept?
9.
9. Whoops. Okay, and which way would we shade, towards or away from 0, 0?
Away.
Once again, away. It's kind of nice because all those signs are the same. Okay. So here we go. Keeping in mind that we're only in the first quadrant because of these inequalities right here, I can see that we have shading right here. I know, this isn't good. Not fantastic. It's easier for you with pencil lead. Okay? What else do we need to determine? Vertices. Oh, you know what I forgot to do? Forgot to label my line, and I am so sorry about that. This was the line 10x plus 30y equals 90. Okay. How many vertices do we have?
3.
I hear 3, I hear 4. Brainstorm and point them out at your table. Brainstorm and point out what you think the vertices are. The black is our shading. How many intersection points are with the shading? Okay, so I think a lot of us are focusing on these two right here, right? Those two are vertices, but so are these. Right, because these black lines are the x equals 0 and y equals 0. Okay, those are also vertices. So Jacob, you were right before. Okay? Those two are the easy ones, right? What coordinate is this? What coordinate is this? 0, 6. Okay? Now, do you see why? Yes.
Is where the purple and the green cross, is that not a vertice?
It is not, because it is not with the shading.
Oh,
Okay, it doesn't bound the shading, so it is unimportant to us. Okay? So don't go through the algebra to find it. Now, do you see why I labeled all of our lines? Okay? We don't care about this coordinate, so it's not worth our time to find. We care about these two. So I have my red and green line labeled so I can find this intersection. I have my red and purple line labeled so I can find this intersection. Okay? Figure out what pod number you're in. Okay? If you're in pod 1, 2, or 3, I would like you to work together to solve for this coordinate, the intersection of the purple and the red. If you're in pods 4, 5, or 6, I'd like you to solve for this intersection, the intersection of the green and the red. What two methods have we been using to do this? Substitution and elimination. Notice how I made them equations here. Take the two equations and work together to solve for those intersections. Do some teamwork today. Neil, which one did I tell you to do?
We're doing the red and green.
Red and green. We're finding a red and green intersection, okay? Wouldn't that be a negative 16? Okay. Okay, as I've been walking around, I'm seeing groups 1, 2, and 3 get the intersection of 3, 2. And groups 4, 5, and 6 getting the intersection to be 1, 4. Okay. Make sure you have all vertices written down. Half of the class helped you on the second vertex point, or the fourth, I guess I should say. So make sure you get both of them written down.
Yeah. She just wrong on mine.
Okay, so this is what I'm going to have you do. I'll keep this up here. We have 20 minutes of class. And for 15 of them, I would like you to start your 4-problem assignment. Okay? Which means I want you to get at least through the first problem. Okay? Is it easier to do problems by yourself or with people you can bounce ideas off and ask questions to with Mrs. Homer around? Probably the second way, right? Okay? So use as much time as you can to work on these 4 problems. Okay? And in the last 5 minutes, we'll talk about our quizzes from Friday, okay? Hold on, Joe, I'm coming. I just want to pause this.